Okay, good morning. So welcome back, and let's see, we're almost done with the the part before the second midterm, and so I think after next week we'll be fully caught up with the syllabus. So if you look here, so we're going to do example. We're going to jump to chapter 14 today and do some examples there for chapter 14 and start that this week and next week, and then we'll do so the I think the coming Monday. We'll do a little review, and I'll post where it's already posted, but we'll talk about the second midterm, and that'll be for next Monday, and then we'll do this one I think next Wednesday, um, and then I think after the midterms due on April 19th, in 2 weeks from, or I guess a week from Monday, we'll be fully caught up. So we're almost caught up from that one President's Day we missed, but I think we'll be fully caught up by Monday, April 19th, and then all this stuff should be the appropriate due date. Okay, so this one today. We'll do a review, do some practice problems for the midterm two on Monday, and we'll do this one next Wednesday, and then we'll be caught up, and those two will be due on the 19th. Okay, and I'll get your homework assignment grades updated this weekend, and those will be posted pretty soon too. Okay, so we're almost 2/3 of the way done, and coming up to midterm, well, take home exam two. All right, so what I want to do today is example 14.1. Okay, so this one you can open up the example 14.1 Word document. You can open up the exponential growth Excel file. We'll start with those. This is the one we're going to be working with. And okay, and so I think so the older version I have posted, this PDF, the third edition or whatever it is. This the I think this is the exercise, but it was chapter 16 before, but this is the same one in the textbook we're using, which is chapter 14. But here's our exercise. So for us, it's example 14.1, but this is forecasting sales at Best Chips. Okay, so let me read the little synopsis that we're doing here. So we're jumping into some forecasting and some statistics and some regression analysis and looking at some business problems there in chapter 14. But the Best Chips Company produces and sells potato chips throughout the country. Its sales have been growing steadily over the past 10 years, as shown in the figure, and we'll show on the spreadsheet. Okay, so here, year one is 1997, so it goes 1997, 1998 for a 10-year period. And the company wants to predict its sales for the next couple of years, assuming the upward trend it has observed in the past 10 years will continue. All right, and how should the company proceed? Okay, so we did the linear trendline analyses where there's a little um, exercise we did, and we did it in the golf club one. But we're going to use some simple trend lines to try to predict do some simple forecasting to kind of take some data that we have and see what the data looks like and use the behavior of the data, I guess, to try to predict what's going to happen in the next couple months. So we'll use some simple trend lines to do some simple forecasting, but it's pretty useful to kind of see uh, if your data does this in the past, then it might do that in the future, and you can use that behavior. So if you look, okay, if you look at the spreadsheet, the exponential growth, there's not much to it, but we're going to do some analyses here. So what we have is the sales. Oh, so they updated it. So this is 2004, and well, it doesn't matter, but we have these 10 years of data, and we're trying to use the 10 years of data to predict the next 2 years. So in year one, this was sales for the Best Chips Company. In year two, this was sales. And so we're in year 10, let's assume. And so based on what's happened the last 10 years, what do we think our sales will be in year 11 and year 12? So it's a nice little exercise if you're running a business or doing some uh, revenue generating project to see, like, based on what you've observed, there's a good chance that what you've seen in the past is going to tell you what's going to happen in the future, and then you can prepare for it in hiring and firing and uh, in terms of the revenue and costs you need to incur. Okay. Okay, so there's a little video that you can look at on time series. And so a time series, just in the simplest terms, is just a series of data that moves over time. So it's one specific piece of data that you look at different periods of time. So this would be an example of a time series, okay? Because you can see that like you have this sales data in year one, so um, you have the same variable over time. So you're looking at the same thing over time, which would be a simple definition of a time series. Okay? So basically, you're looking at anything over time. And so this will be our first kind of look at time series. And our time series here is just how the sales data behaves over time. Okay, so this is example 14.1, forecasting sales at Best Chips. All right, so the first thing we're going to do is we're going to look at what the data, we're going to make a graph of the data. So normally for these, if you have a piece of data or a time series, you kind of want to see what it looks like. So step one, the first thing we'll do is just create a scatter plot of sales over time. Okay, so we can go to the model. Okay, if you want to just select all the data, actually select it with the the 11 and 12. So select everything basically like this. Okay, if you just select A1 to B13, all right, all this, everything you've got. Let's just go ahead and select that and do insert. And you can do, there should be like a scatter option here up near the charts. So you can do this and then scatter. So you want a scatter plot of the data, of the sales data over time. All right, so we'll do some formatting, but you should get something like this, where you have the sales time series, where this is the, down here, this is the year, and up here, this is the sales data. So, all right, so these little dots correspond to what you have over here. So this is number one, right? So you can click on it and see that that's 1 and 1,345,000 and so on. So we just plotted these points, and you can see there's kind of a little upward trend, and we can, unless we have any prior behavior of why this would change, we can probably assume that the sales data is going to continue to increase for the next couple of years unless something happens. But yeah, so here's our time plot that we want to look at first, kind of just see what it looks like. All right. Okay, so we got that. Okay, next thing we'll do is just do a little bit of formatting. So this will add some labels. Okay, so remember there was a couple ways to do this if you're using a Mac or a PC, or Windows. So there's chart elements if you're using Windows. So if you click on the chart and click on the plus sign for chart elements, you can unclick chart title and click axes titles, and we'll put the axes titles there. And I think the Mac way was if you have this, click on the chart and click on format, or is it chart design? Yeah, chart design. And over here, you can click on add chart element, and you can click on axes titles and choose them both individually. So there's two ways to do it. You can do it if you have the shortcut with the plus sign with the chart elements, or just click on the chart, click on chart design, and then go over to chart elements, and you should have the same features that I'm getting to here. All right, so this axis title is just what it says. So this is sales and this is year. So we can put that in. Okay, that's sales. This is year. All right. What do we do now? Okay. So the next thing I'd like to do is make this the see how the x axes labels aren't the same as over here. So I wanted to say 1, 2, 3, 4 all the way to 12. All right, so it makes sense with what's over here. So we can fix that. This might take a few shots, but we've done something like this before just to change the formatting. So if you click on the x-axis, see how this box selects just the numbers, the labels, and you right-click it, and you choose Select Data. That didn't work. Okay, don't do that. All right, so let's try that again. So click on the box and then right-click it, and then choose Format Axes. Let's try that. Yeah, this will work. Okay, so over here you see the Format Axes little box. Um, let's change the minimum to 1 and the maximum to 12. All right, and let's change the units, the major units to 1, so it'll count 1 to 12 in increments of 1. There we go. So min is 1, max is 12, and major is 1. And then see how you close this? You'll get it so the year goes just like you see here. All right, so we essentially have the 10 years that we've observed data, these 10 dots, and we're trying to predict years 11 and 12. Okay, so were we able to get the labels changed here for the year? Did that work?
Yes.
Okay. Okay. Next step. Next step is we're going to add a trend line. We've done this before. We're going to do a linear trend line. We haven't done the forward forecast box, which we're going to do now. So we're going to forward it 2 periods. All right, and I'll show you how to do. It's just checking a box, and then we'll display the equation on chart. So we've done this before. The only difference is we're going to extend the line 2 periods to see which is basically our prediction. So go back to the spreadsheet. Okay, so again, there's multiple ways to get to this. I'll do it this way first. So trend line, click on the plus sign for chart elements. Scroll down to the trend line thing and click on the arrow, and then click on more options. Okay, so over here you see the options. Leave it as linear, and what you want to choose is see where it says forecast forward. Put a 2 in there to forward 2 periods, and then go ahead and choose the box that says display equation on chart. Okay, so here we got the linear trend line. We're going to forward 2 periods, so we're going to display the equation on the chart that's going to look like that. And we'll fix this in a minute, but you should have that. And then the way to do this, if you're using the top menu or a Mac or something, is like this. Remember? Oops. Okay, so you got the chart clicked. Click on chart design, add chart element, and then trend line. Why is it not? We should have trend line, more trend line options. Why isn't that there? There we go. Sorry. Yeah, so if you're going this way, let's do that one more time. Chart design, add chart element, trend line, and then more trend line options. And then just choose the same thing. So if you're going that way, get to that box, choose linear, forward 2 periods, and display the equation on chart. So either way, if you're using a Mac or Windows, that should get you to it. Okay. So you got your trend line, and see how it goes 2 more years, right? So we're basically assuming that, or we're simplifying, saying that if this has happened in the past, let's just assume our best cases or most likely cases is going to continue something like that in the future. All right, and this is our equation. So the next thing we'll do, uh, is format this equation. So if you want to click it, right click it, format trendline label, and just change the category to number. And let's go ahead. We've got too many numbers here, so let's put it at number, but let's put our decimals at 0. Okay, so category is now number with 0 decimals, and it should look something like that. All right, so we got big numbers, so let's just get rid of the decimals to make it a little easier to see. Okay, so you should at this point have your time plot with your sales, your years 1 through 10, and the 2 additional forecasting years 11 and 12. You got your trend line, and you got your equation like that. Yeah. Okay. So I guess we're doing. I forgot we're doing a second trend line, but okay, we did number 2 already, right? Number 2 is just format the trend line label and change it to number with 0 decimals. So we did that. That's done. Okay, so step 3 is let's go ahead and uh, repeat the analysis, but we'll do a exponential trend line and kind of get the equation and the prediction for that. All right, so let's do a trend line. I guess we'll have to make a copy of the chart. We'll do another trend line, forward 2 periods, get the equation. The only difference is we're going to check exponential as opposed to linear. So let's do that. Okay, so I think easiest thing to do is let's just click on the chart and copy and paste it, and then we'll fix the other one to be, actually, yeah, let's do that. All right, click on the chart, um, copy it, Control C, and just click anywhere over here to the right on some other cell and hit and paste it, Control V. There we go. And then this one over here. So the first one we just did, maybe let's add the title to call this one linear. All right, so I think we took the title away, but since we have 2 of them, let's go ahead and put it back. So the first one, the left one that we just did, click on the plus sign and go ahead and use or go ahead and check chart title, and let's call this linear. Okay, so there's that one we just did, and again, you could also do click on it, chart design, add chart element, and chart title. You can choose that as well. Okay, so now this one, we will do the exponential trend line. So let's click on this one to the right. Let's click on the plus sign. Let's click on, all right, unclick the trend line, and then click the arrow, and then more options. Okay, let's specify what we want, which is exponential, and forward 2 periods, and display equation on chart. Okay, so it's only same thing as last time, except we chose a different option for the type. So exponential, forward 2 periods, display equation on chart. Okay, and again, to do it the other way, click the chart, click on chart design, click on add chart element, click on trend line, and click on more trend line options, and that'll take you right back to the uh, little box where you choose your options. Okay. All right, let's do a few more things with this one. Let's add a title for this one. If you click on the plus sign and chart title, let's call this one exponential. Okay, and we can also, all right, again, you could do chart design, add chart element and chart title there. Another way. Okay, last thing before we do some more is let's click on this this equation for the exponential. Let's format it so it's a little bit easier to read as opposed to the 1e plus whatever that is. Click it, right click it, format trend line label. Let's change that to number, and that looks good. So in this one, let's leave number in 2 decimals, like that. Okay, so what we should have here is the linear and the exponential, the two trend lines, and the two equations. Okay, and we'll kind of compare and contrast these. But what we're trying to do here is look at some different types of equations, a linear, exponential, see which one is in the past 10 years capturing the data better, and the one that is capturing the data better. When we do some error checks, we're going to use that one to get our predictions um, for the next couple of years. Now, the title of this exercise probably foreshadows the answer. Like it's called exponential growth. So there's a good chance that we're going to choose the exponential, but we'll do the full thing. Okay. All right, everybody, good up to this point? Okay. All right. We've done step 4, I believe. We formatted the. All right. So steps 1 and 2, we're do the linear trend line, format it, and steps 3 and 4, we're do the exponential trend line, format that. We've done that. All right. Now let's set this up a little bit so we can get our predictions and our absolute percentage errors, and we'll see which one has the lowest mean absolute percentage error, the MAPE. We've done that a few times, right? So see how I put the screen cap here if you don't have the book, and let's set it up. Let's put these titles for predictions and absolute percentage errors and MAPE, and we'll set it up like this. So let's just format the spreadsheet a little bit so we can put in our numbers. Okay. Um, what are we gonna do? So actually let's move these graphs down a little bit. Okay, so it won't mess anything up, just moving the location. So I'm gonna move this one down here to like right there, and I'll move this one down to maybe right there. Okay, and we'll refer to those in a minute. Um, I want to add I want to add a title up here. So let's bump the data down a little bit, or just one row. So if you click on the one like that, the one row, and just under Home tab, if you hit the Insert button up here, all right, that'll bump it down, and nothing gets messed up. See how it's all, except if you move things around, it kind of keeps it as how you had it. All right, so see this is fine, and this is fine. It's still the same data. All right, we just moved it down one. Let's put the title for this little section. Let's call it in A1, historical data. Okay, and the row one is going to be all the titles. So if you want, you can click on the one, and you can make all this stuff bold to represent the title. Just hit the B, or Control B would also do that. Okay, and then over here in D1, we're going to put predictions. So let's call this title predictions in D1. Okay, and then right here in D2, this will be the linear. And E2 will be exponential. Okay, and then in F1, the title here for this little section for the errors is going to be absolute percentage errors. Okay, and then we'll put a little section for the linear in F1, F2, I'm sorry. And FG2 will be the exponential. Okay, and then E16, if you go down there, E16, this is where we're going to calculate the MAPEs when we're done with this part. So go ahead and put MAPE here. Okay, and E16, and we can make that bold too if you want. All right, so we're going to do the calculations in a minute, but just set it up like this. So this is our historical data with the year and the sales we had. All right, we put a little section for predictions for linear and exponential, which are going to go here and here. And we put a little section for absolute percentage errors with the linear and exponential that are going to go there. So we're just setting it up so we can get our everything in the right spot. Okay. Yeah. All right. Okay. So we got it looking just like this. Okay. Step 5 is we're going to get the predictions in the sections we set up in D and E, D3 and E3. All right, and we'll copy it down. And we're going to put in the parameters that we got from the trend lines, right? And that's exactly what we're doing. So let's go ahead and use, right, these are the equations, but let's just use the ones that we got from uh, the trend lines so we know exactly they're correct. So go ahead and go here. Okay, and see, we've done this before, but what we're doing is for the linear, we're gonna specify the linear equation that we got from the trend line. And for the exponential, we're gonna specify the exponential equation that we got from the trend line. So we're gonna essentially put this and this in their spots, and the x is just time. So we're saying that each year the behavior of the linear follows this pattern, and the behavior of the exponential follows this pattern, where y is predicted sales, and x is time, or just year one, year two, etc. Okay, so let's go ahead and specify this one first. Um, so we're going to say that um, y equals, so here we're in D3 equals, I'm just looking at this, 1, 168, 200, plus, here's our slope coefficient, 92091, times x, and x is time, so the first time is this one, A3. Okay, so again, if the numbers are coming from right from here, from the linear trend line, so equals 1, 168, 200, so 1,168,200 plus, in parentheses, 92091 times A3. Okay, enter. All right, and then we'll format this in a minute, but well, actually, let's do the exponential one first. Then we'll format it, and then we'll apply it down. So the exponential one goes here in E3. So now we're going to specify this equation, see it down here, for the exponential. Um, and then x is the same thing. It's going to be A3. Okay, so in E, y equals um, this big number, 1, times ex. There's the exponential shortcut or the formula exp. There it is. And then this number, the um, 0.05. Okay, times x, and again, x is a3. Okay, so for this one, I'm taking the number from here and just putting in, specifying the equation equals 1,227, 762.17, right, times exp, and then in the parentheses, the exponent's raised to 0.05 times a3. Okay, enter. Okay, let's format these two as currency, and then we're going to apply the predictions. So we've set the equations up. Next step is I want the numbers to look like this format. So click on this one and choose that one. So if you got the equations, you can select D3 and E3, and then Home tab, um, Format, Format Cells, Currency, and we don't need any decimals. We got big enough numbers, so take the decimals down to 0, and you got the $ symbol, and hit OK. So you got that. All right, there we go. And then, if you got this selected, best thing to do is, because you don't have a reference point to, you don't want to double click because there's nothing here, but just grab the bottom right corner and apply the formulas down like this, all the way to there. Okay? So this, see how this should be the same formula, but it's changing the A number reference, okay, all the way to year 12 for A14, right? The linear and the exponential, see how it's the same formula with the year is changing, and double check your last one is A14 to refer to year 12. Okay, so what we've done is these are the predictions for what we've observed in the linear data, and these would be the forecasts using that same equation. This is what we've observed in these are the predictions for the exponential for years 1 through 12, 1 through 10, and these would be the two predictions for the future 2 years. Okay, so
Wait,
predictions.
Professor,
Yeah, yeah.
uh, what format did you use again?
Oh, so it's just if you're selecting these two, you want to go under Home tab, Format drop down, Format Cells, and just change it to currency, and just make sure that your decimals are at 0 and your symbol has the $ there. That should do it.
Okay, thank you.
Mhm.
Can you show the formula for the E?
E3?
Yeah.
Yeah. Okay, here it is. Yeah, so it's just again we're taking it from this equation, but with the exponent it's equals 1,227, 762.17 times exp, the exponential formula, and then in the parentheses 0.05 times a3, and that should do it.
Thank you.
Yep. Okay, so everyone good here? We got these numbers. You got the formulas. You copied them down. You formatted them. So we got the same numbers as we're looking at here. Yeah. Okay. All right. Next step is to calculate the absolute percentage errors for each year, and then we're going to go ahead and see which one has the lowest absolute percentage error on average, which is the MAPE. So let's do this first, step 6. is we set this section up. So in the absolute percentage errors section, we're going to calculate those absolute percentage errors for each year, for the linear and for the exponential in this column and this column. So here's our equation for the first one, and then we can apply it across. And we might have to format this to be percentages, but we'll put the formula in first. All right, so it's equals. This is F3, and F3 equals ABS, absolute value of $B3 minus D3, parentheses, divided by, or slash, $B3. Okay. Actually, let's add another parenthesis just so this is work. So let's make sure this is the absolute value of all this. So go ahead and put a parenthesis on the outsides like this. Yeah, there we go. That looks better. Okay, so equals absolute value of, so this is, remember the absolute percentage error is just the percent off from the prediction. So it's always actual minus prediction over actual. So actual sales is here in blue, prediction is here in red. So it's absolute value of B3 minus D3 divided by B3. So we're saying, what's the difference between these two? Between the prediction and the actual, and how far off was that from the actual sales? So the difference over the original in percent terms is the absolute percentage error, how far off it was, how far off this was from this. And it was about 6% off. Okay, and I think what we can do is just format this one to be percentage and then apply it to the rest of the region because we set it up with the dollar signs. So if you got this equation, click on F3 again and change, I think just under Home tab, see up here with the drop-down menu, or actually just hit this, see this button here that says percent style? Hit that. Okay, hit that percent if you have that. And then maybe let's add 2 decimals. See how it says increase decimal? Hit that twice. And that should put it at 6.30%. So here again, there's the percent shortcut. And this little thing with the zeros left or right increases or decreases the decimal. So you can get it to format like this. Yeah? And let's go ahead and apply this formula. Just grab the bottom right corner and drag it over like that to the exponential, and then leave it selected. So you got F3 and G3, and then just double click the bottom right corner like that, and apply it down. And the reason we can delete these, but the reason we don't have errors here is because we don't have data. So there's nothing here because we don't have anything to reference it to. So you can delete this stuff. Okay, but you should have this. So you should have your linears and percent errors here, all the way down from year 1 to year 10, and you got your exponentials here, all the way down from year 1 to year 10. Okay, did we get that with these? We got these numbers here in percent terms.
Yeah, Professor, I'm getting something's wrong with my percentages. Could I see the exponential equation again?
Yeah, here you go. Okay, so it's for the exponential, it's the absolute value of the actual minus the prediction over the actual. So it should say, if you copied it right, equals ABS double parenthesis $B3 minus E3 parenthesis divided by $B3.
Can I see it for the predictions?
For this one? Yeah, the exponential?
Yeah.
Yeah.
Wait, can I post it? I'm not sure what's wrong.
Yeah, go ahead. Yeah, just post it to, what is this, example 14.1? And yeah, then I'll take a look at it.
Can I also post mine? I think I had the same problem.
Yeah. So yeah, let's if you got it, if you got something you want me to look at, yeah, this is. I'll see what I can if I can figure. I'm sure. Okay. All right. So double check your. So I'll do one more step and then I'll take a look at these. But all we're doing next is going to calculate the mean absolute percentage error, right? And that is step 7. Okay. So we're just going to get the average, right? In this step, right here, and then we'll take a minute. I'll double check these other ones, but if you want to do the next step in the MAPE, just go here in F16 and take the average of that. So in F16 equals average. Average of F3 to F12. Okay, average of all these. Enter. And just drag it over like this. So this one should be the average of that. Okay, so you should get something like 3.14% for the MAPE for the linear and something like 2.72% for the exponential. Okay, so let me take a look at those that got posted. If you didn't get these numbers, let me know, or you can post yours too. Okay. All right, we'll do Raymond first because you posted it a minute earlier. Okay, let's see. Okay, I think those look good. And for the errors, um, oh, so this one, oh, the reason why yours is a little bit off, Raymond, is just because you didn't add, there's no space here. So you can leave it, and for yours, let's just do, so go to, see what I mean? Like, um, the reason why it was D3 is because I had a space here. See?
Oh, okay.
Yeah, but it doesn't matter. So just for yours, just do this. So for F3, yours should say equals ABS, and that B3 minus C3. Okay, so change the D3 to C3 like that. See how it's got the linear now? Enter.
Okay,
And
got it.
once you do that, you can just drag it over like that, and then it should give you the same things like that.
Okay, thank you.
Okay, that work? Yeah.
Yeah.
Okay. All right. So yours is good. Close that. And then the other one. Okay, let's see. Looks like we got some problems over here. All right, so first thing, Ryan, let's fix this equation.
Okay.
D3. So this should be, I think everything's right except for this should be A3. Okay, so it should be that plus that, and just change the reference to A3 to get the year. So see how it's doing that? So that should be A3. All right, and so once you fix that, I think if you drag this one down, that'll fix those ones. Okay, so it's the same equation, but now it's A3 all the way down to A14. Yeah, and then this one, what's that?
Nothing. Sorry.
Okay, oh, no problem. All right, and then this one, again, this should be A3. Yeah, so that's okay. So it should be the same thing you have there, but just change the number from B3 to A3. Okay, and that should do it. Hit enter. And then drag this.
Okay, that fixed it all. Yeah.
Yeah, and then drag that one down. Okay, so we got that. And then did that do it?
Yeah. Thank you.
Yeah, and then just change these to percentages. I think that'll do it.
Okay. Thank you.
Yep, you're welcome. Yeah, there we go. Okay. All right, so if everyone else has got this, what we've done is we've looked at we've calculated the MAPs. The question was, oops. The question was, which trend line is better, and what are our sales predictions going to be for years 12? So we've done the analysis, but what does it mean? Um, so the point was to look at the data, look at a couple techniques, exponential, linear, see which one captured the data better in the past, and whichever one did capture the data better in the past, we're going to use that one as our best case to predict the next 2 years. All right, so you can see that the linear MAP was 3.14%. So both of these were pretty good, but this one was 2.74%. So just based on this metric, this one had a lower error, the exponential, which means that this one essentially captured the past data better. So what that means is that this dotted line captured the points better than this dotted line. So we're going to go ahead and use this one. So I'll just highlight that as our choice. Okay, and so since we're choosing this one, our predictions would be the predictions for the exponential, right? So if we're using the exponential, then this is what it said was in the past. And so if we extend the line like it did down here, that means that this one would be our prediction for year 11, and this one would be our prediction for year 12, right? Okay, so that's our lower percentage error. These would be our predictions. Okay, these two over here are the predictions for the linear, but we're going to go ahead and use this one because it had the lower error, right? So that's the idea here. Okay. All right. Yeah, everybody got that?
Wait, Professor, could I see the equation for the MAP?
Oh, sure. Yeah, it's just the average of the column. So this one is average equals average F3 to F12. And this one is just average G3 to G12.
Okay, thank you.
Okay? You're welcome. Okay, so we're done with the spreadsheet. I want to do one little practice problem, but the assignment part is done. So if you've got this done, exponential growth, go ahead and save it. And that's going to go in the exponential growth section. Okay, so that goes there, and that's due by next next Monday, right? Yeah, next Monday. Okay, so example 5, 7, and 5, 7, and 14.1 due next Monday. Okay, but let's do a quick practice problem that kind of relates to this because there might be something like this on the take-home exam. So example 14.1, example 14.1 practice question solved. Okay, so an example of something where you can um, do a problem based on that type of exercise. So here we go. We got something similar. We got different years. I mean, we got the same years, but we got different sales data, and we got the different predictions and the different absolute percentages. So the information that's missing is what you can figure out or calculate. And so we got here's our screen cap. Here's our sales trend line with the equation, and here's our sales exponential trend line, so linear and exponential given the equations. And the questions are part A, you could answer. You could calculate an APE for something that's missing. So part A, refer to the screen cap of the exponential growth model, and using the linear model first, calculate the APE for year 10. All right, and so remember the APE is just the actual minus the prediction over the actual in percent terms. So see what's missing for year 10 is that. So you're calculating this blank number. Uh, so you know that this is the actual 2,000, 2,002,000 for year 10, and this is the prediction for the linear. So you're trying to see how far this was off from that. And so it's just absolute value of this minus this divided by this, right? Okay. So the APE for year 10 for the linear is the actual 2,002,000, 2,200,000 minus the prediction for the linear, 2,075,453 divided by the actual 2,200,000. And if you put that in a calculator or calculate it, you'll get in percent terms about 5.66%. Okay, so all you gotta do is know how to use, I guess the equation's given here, but you just gotta know how to calculate the AP based on the information given. All right, so we got that one. And the next question, you're gonna get this one, which is missing. B, using the exponential model, okay, calculate the AP for year 10. All right, so same equation. The only difference is you want to see the AP for the exponential. So here's the exponential prediction. This is still the actual, so it's going to be this minus this over this, right? Okay, exponential, APE, year 10, actual, 2,200,000 minus predicted for exponential, 2,094,105 divided by actual, 2,200,000, and that gives us about, in percent terms, and also make sure you take the absolute value. So if you get like negative 4%, just convert it to 4% because you're looking at the difference, not the sign. So make sure you take this calculation, and the AP is absolute. So remove the negative sign, and if you remove the negative sign, you'll get 4.81%, something like that. Okay, and C. Which model predicted the sales data better in year 10? Okay, so if you got the numbers right, you see that this one's 5.66, this one's 4.81, this one's lower. All right, so essentially for that year 10, the exponential model was a little bit better because this error was lower than that error. So the exponential, because the 4.81% is less than 5.66%. Okay, so that's all you got to do the calculation. Again, don't forget to remove the negative sign because it's not like if one is negative, one is not. Make sure it's absolute terms, not negative. So if this one was -5%, that's not lower than this in absolute terms. So make sure you take the negative sign away before you do the comparison. Okay. D, part D, calculate predicted sales for year 11 using the linear trendline parameters. So all you gotta do is here's our linear, right? Here's our equation. And so use that equation and just plug in x. Okay, so type out this equation. Sorry, 91,000, or I usually start with this one, the intercept. So 1,163,333 plus 91,212 times x. And for this type of equation, or for this type of exercise, you want to know what your x term is. This is the time series, which means that the x is just time. So for whatever time period it is, you're going to plug in that for x. This asked for year 11, so your x is going to be 11. If it asks for 12, the x is 12. So it's just whatever point of time it is based on this exercise. So like this is x1, x2, but because you're looking at what happened in the 11th year, you're going to put in 11 for x. So take this equation, plug in 11 for x, and that's what your y11 is. Okay, y is sales. So sales in year 11 is 1,163,333 plus 91,212 times 11, and that gives you something like this: 2,166,665. Okay, so the equation's given right there. All you gotta do is take that equation and know what to plug in for x, which in this case is time, and time here is 11. All right. E, calculate predicted sales for year 11 using the exponential trendline parameters. Okay, so use the other equation, this one, it's kind of a big number, but you can put that in your calculator. So you got 1,220,336.107 times E raised to 0.054 times x. So again, just take that equation that's given and plug in your x. It's the same x, different equation, but x is 11 because we're asking for year 11. Okay, so we got sales predicted for year 11 equals 1,220,336.107, and then times E raised to 0.054 times x, and x is 11. Okay, so you put this in your calculator. All right, make sure you get this calculation right, and E is just the number E. Like, there should be a spot in your calculator or whatever, but it's like 2.17 or something like that. But this comes to 2,210,296. All right, and then also just when you get your numbers, your predictions for these, just go ahead and double check that they look something like in the realm of what they should be. So these are both in the 2 million ranges, which is that looks right. Right, that's 2 million something, because you're essentially calculating the number 11 on the line. So that number and that number, and those both look like they're about right. So 2 million something. If you got like -5 or 100 million, that's probably not right. So just double check that the numbers you're getting make sense given the graphs here. F. What does the slope of the linear curve imply exactly? So remember, the slope of a linear curve or linear model is just the change in y if you change x by 1 unit. Now, x is time here, so this is a time series. So this means that if we go up in time by 1 unit, this is this number, 91,212, is essentially the increase in sales. So what we're saying is that on average, sales go up by this much every year. Okay, so x changes by 1 unit, which is 1 year. So what that number means, that 91,212, that's the average annual increase in sales each additional year that we've seen. So that means that, you know, this going from 1 to 2 is a plus 91,000, going from 2 to 3 is a plus 91,000, and so on. So this line increases on average by 91,000, 2 and 2. So what that means is over the 10-year data set, sales increase by 91,212 per year on average. And that's exactly what you did with the year 11 prediction. You just basically added another 91,000 for the next year. Okay. All right. So questions on any of these practice problems that refer to the model here? Okay. Okay, so double check that you can get all these. There'll probably be something like this on the take-home exam that we're going to talk about next week. But I think that's what I want to cover for today. So it's time. Okay. There are 2 assignments due on Monday, which a lot of you have already turned in. But example 5.7 that we did Monday, and example 14.1 that we just did today. Post these. These are due next Monday, and then the coming Monday, we'll go ahead and prepare for the second midterm. So Monday, make sure you come because we're doing a little review and some practice problems for the second midterm. And then next Wednesday, I want to go ahead and go back and do this one. We'll do a little extra credit for the time series. Okay, and then both of these 2 things will both be due on the 19th, and then we'll be all caught up. Right? So the first meeting after the midterm, the second midterm, I believe, will be all caught up. And these due dates, assuming nothing goes, you know, we don't get behind, I think all these due dates are right. Okay, so I think that's what I had planned for today, and that everyone have a good weekend, and thanks for coming, and I'll see you on next Monday.
Thank you.
Thank you, Professor.
Thank you.
Thank you.
Thank you.
Thank you.